We are going to see how to take a derivative and an integral of a vector valued function. And as we read, this is nothing more than taking the derivative or integral of each piece, but we'll still benefit from seeing an example of it. So let's take the vector valued function r of t equals cosine 3t, t e to the 2t, and t squared. So a vector valued function, we have the one independent variable t, we have three dependent variables or three outputs as listed here. And for the derivative, we just take the derivative of each piece. So the derivative of a cosine is a negative sine, so I have negative 3 sine 3t. There's a chain rule in there as well, right? The derivative of 3t is 3. For the second component, we have a product, so we'll use the product rule. The derivative of t is 1, so we have e to the 2t plus 2t e to the 2t. Again, some chain rule on that second part of the derivative. And then the derivative of t squared is just 2t. So the derivative of the vector value function is another vector valued function. We'll see the geometry of this in the reading and in future problems, but this is how we do the derivative. For the integral, we just take the integral of each piece, right? So we have the integral of the cosine of 3t dt, the integral of t e to the 2t dt, and the integral of t squared dt. And this could be as easy or hard as any of our integration techniques, right? In this case, a couple of these are straightforward. The integral of the cosine is a sine, so we'll have a 1/3 sine 3t, and I'm going to say plus c1. There's a constant in there of integration. For the second one, we need integration by parts. So I'm going to let u equal t, then du is dt. That leaves the rest of that integrand. dv is e to the 2t dt, and the antiderivative of that is 1/2 e to the 2t. So the integration by parts on this is, this integral is equal to uv minus the integral of v du. So that's t over 2 e to the 2t minus the integral of v du. So 1/2 e to the 2t dt is what we have. I can do that integral. I'm going to put the answer in the slot for it up here. I have as an integral then after integration by parts t over 2 e to the 2t minus 1/4 e to the 2t plus c2. And then the third integral, the integral of this z component, the integral of t squared is t cubed over 3 plus a third constant. So we've taken both the derivative and the integral of a vector valued function. All of the things that we need about derivatives, chain rule, product rule, quotient rule, can come into play here, and everything that we've learned about integrals, integration by parts, u substitution, partial fraction decompositions, all of that can come into play here, just depending on what our functions are in the vector valued function. But that's how it's done.